Good morning, party people, and welcome to How to Think Like the Engine Demo Edition. There are two ways that I do this class. One way is with the doing PowerPoint slides. The other way that I do it is in SQL Server Management Studio, done entirely with demos and no slides whatsoever. They teach slightly different things. They start with the same basic concepts, but then I can go down different routes based on your questions. So if you're watching just the stream on BrentOzar.com, you can click on the chat link down below, and then you can pop open the YouTube chat where you can ask questions or say good morning, like so many of these folks are doing. Now, I am going to start with just a couple of slides showing where to get the database. Then we're going to pop over into Management Studio, but let's start by switching over to just those slides. So everything that we're going to talk about today is over at brentozar.com/go/engine, including a 5-page PDF with a bunch of demo data from the Stack Overflow database. I say this because it is really helpful to have these in hand as I'm going through and talking about the differences between, say, the clustered indexes and the non-clustered indexes. I'm going to be holding them up too while I go and run queries against them, but it just helps to visualize that data. Also, at brentozar.com/go/engine are links to the Stack Overflow database. I'm going to be working in the Stack Overflow 2010 database this morning. It's the smallest database that I distribute in terms of real data from Stack Overflow. You can download that directly from that URL, as well as get the original source data from the kind folks who are so nice to provide the original source data. So now, having said that, let's go hop in and let's go jump into the demos. So let's go hop over into SQL Server Management Studio and let's talk a little bit about my setup here. So I am working with SQL Server 2022. Oop, let me switch over to the right window on my side. SQL Server 2022. Oh, that's a little weird how it's not quite getting the green screen piece right there. I wonder if I need to brighten up the lights in here a little bit. Let me amp up my lighting just to see if that helps, because I don't want you to be distracted by anything. It's hard enough to pay attention with my training. Here, hold on. Let me tweak something just a little on my end to adjust that. It's funny. It wasn't doing it yesterday, but it was because it's broad daylight in my office. So that would affect how that works. Perfect. That's much better. Okay, so I am working with SQL Server 2022, and I've got my Stack Overflow databases in 2022 compat level. That's going to make a difference if you're going to try to follow along on your machines. And there's no demo scripts to download. I'm going to be typing everything right in front of you. So before you leave a comment on the video or on the replay saying, hey, Brent, can you paste the script somewhere? You just pause the screen and type whatever it is that I've got in there so far. So I'm going to be working with the Stack Overflow 2010 database. So let's make sure that we've got our database context set to that. And I'm going to start by introducing the table. I'm going to say select star from DBO users, and I'm not even going to put a where clause in it. I'm just going to flat out execute it, because in the tiny Stack Overflow 2010 database, it's just not that large. The users table is the smallest table inside this database. The users table holds exactly what you think it holds. It holds a list of everyone who's ever logged in, posted a comment, posted an answer. I'll zoom in a little bit so you can see the basic structure of the table. It's organized by ID, starts at a low number and then gradually goes up to higher numbers. ID is an identity column, an integer. And you can see way over there on the far left-hand side, there is an ID column on the table with a little key next to it. That's Management Studio's way of indicating that this is the primary key of the table, also known as the clustering key. Those two aren't always the same, but usually they are. When we say the clustering key of the table, what we really mean is that on disk, the data is sorted by that column. Generally speaking, you want to have your data sorted by some kind of column, like in this case we're doing by ID. So if you think about how the data looks on disk, it's kind of like a set of spreadsheet pages, a bunch of 8K pages organized just like an Excel spreadsheet, and stacks of them. Your database just consists of a whole bunch of 8K pages. Each page is dedicated just to one object, like in this case, just the users table. And if I want to go find data, I have to pull these 8K pages up into memory in order to find the data that I want. These 8K pages are exactly the same whether they're down on disk or whether they're up in memory. I always hold things up here as if it's inside of my own memory. This also affects the way that SQL Server does inserts, updates, and deletes too. When SQL Server has to write data, if you're going to add data to a page, SQL Server has to pull the related data up into memory, pull the related pages up into memory, make whatever changes it needs to make, and then flush these 8K pages back down to disk. So how many pages are we talking about here? The way that you find that out is you run a command called set statistics IO on. Set statistics IO on is totally safe to do. It only affects your own session. Let me move down here just a little. There we go. Only affects your own session. And then what that does is it tells SQL Server to add a little bit more data over in the Messages tab of SSMS. Over in the Messages tab now, it says logical reads 7,405. That means 7,405 8K pages. That's how big this table is. So when we're thinking about how SQL Server executes queries, I want you to think of having a stack of 7,405 pieces of paper in your office somewhere, like a big old pile of like 15 reams of paper, that if you're going to find data, SQL Server has to work through all of that data in order to find it. So to understand what work SQL Server does whenever we run queries, I like to turn on this little option here called Include Actual Execution Plans. including actual execution plans, lets us see what SQL Server did in order to execute the query. In this class, we're going to be coming up with our own execution plans in plain English before we look at SQL servers. For example, if I gave you this query and said, hey, I want you to figure out how to select all of the star from users, all the stuff from the users, your answer would be, well, I'm going to take the table and I'm going to grab the first page, I'm going to scan through it, yelling out all of the data. Then I'm going to go grab the next page, scan through it, reading all of the data. That's exactly what SQL Server does. To see it, let's switch over to the Execution Plan tab. The way that we read these execution plans is we read them from right to left. That's not the only way to read it. There are several different ways to read it depending on what you're trying to do. But most of the time, you want to start at the top right operator because it's the thing that SQL Server did first. And I love these little operators or these little icons because they kind of show what SQL Server is doing. This is the concept of the data as being stored in a B tree. That's going to be the only time that I mention that during the class. But SQL Server is going to scan through all the leaves in the tree. The terminology for these is leaves. SQL Server and other databases don't think of these as pieces of paper. They call them leaves. I think that's utterly stupid because you don't write things you want to keep around on leaves. You write them on pieces of paper or stone tablets or whatever it is that you have there. So here we're going to scan through all of the pages, start to finish, reading out all 299,000 of these users. You can also hover your mouse over here and you can see down at the bottom there's an output list. And this is whatever we wanted for our query. In this case, we said select star, so SQL Server is outputting 299,000 of these. Now, I probably don't, for the sake of this, I don't want to be doing select star throughout the whole entire class. So instead, I'm just going to get the ID column in order to make things easier. Now, if I get less data back, like in this case, I only got the ID, is that less work for SQL Server? If I only want the IDs back, is this somehow lighter weight? Well, I still have to scan through all of these 8K pages because the IDs aren't stored by themselves. They are in a different kind of index called a column store index, but that's a subject for a totally different class. If I want to get all the IDs, I still have to scan through this whole frickin' table. And I can get an idea of that. If I go over and look at logical reads, the number of logical reads isn't any lower. I still have to read through 7,405 pieces of paper. This is one of your first lessons. Just because you select less data doesn't mean that it's necessarily going to be less work. If the data isn't organized in a way that supports the query you're trying to do, then it's still going to be a whole heck of a lot of work to go scan through all of those objects in order to find the particular parts that you want. Now, let's try changing our query a little here. Now, a second ago, I tried to just only select ID and not select star. Let's try selecting something else. Instead of getting all of the users, let's get some of the users. Say where last access date is greater than 2014-07-01. And let's take a look at that execution plan and see how that one looks. It looks really similar. There's a new step inside here, parallelism. We'll get to that in a second. But even though I'm only asking for some of the users, only the ones where last access date is greater than 7/1 of 2014, I still had to scan the whole table in order to find them. Because these 8K pieces of paper, they ain't organized by last access date. We said right from the beginning, they're organized by ID. That's what that little key was. When I looked at the table design structure, if I go back over into Object Explorer, whoopsie, made the mistake of clicking in there. So it shows ID, it has a little key next to it. That means that's how this table is organized. There are exceptions. You'll learn very quickly. Some of you have been doing this for like 20 years. You're like, well, actually, under some cases, Brent, zip it, Speedy. You shouldn't be in this class. You should still be taking notes rather than trying to teach it. You're welcome to teach your own class. Just look for the YouTube channel that has your name on it instead of my name. So now over here, we had to scan the whole entire table. And to prove that we had to scan the whole entire table, let's look at it another way. Let's look over at the messages. Let's look at the number of 8K pages that we read. Then it's higher. It's not lower. It's actually higher. How did we read through more 8K pages? Well, that has to do with something else that SQL Server put into this execution plan, parallelism. So say that you have to go scan through the whole entire table. You probably don't want to do it just yourself. You probably want to bring several other people with you into the office supply closet to go through those 15 reams worth of paper. And you might be asking, well, Brent, we had to scan through 15 reams worth of paper last time. How come SQL Server didn't get parallelism involved with this? That's a great question. You're so smart. That's why I really enjoy having you attend these classes. The reason why is that now SQL Server is only returning a subset of the rows here. SQL Server is only returning some of the rows. Last time I didn't have a where clause, so every row that I found, SQL Server could immediately start yelling it out that output arrow there, and immediately keep our network pipe busy going out to whatever application asks the stupid question of give me all the rows without a where clause. But now that we're only returning some of the rows, SQL Server says, well, why don't I divide this work out across a bunch of people, across multiple CPU cores? Because as they scan through, they won't be immediately finding lots of rows. They'll only find some of the rows. So it'll take several workers to keep a single network pipe busy on the way out. Automatic parallelization of queries is something that I really enjoy in SQL Server. I love that SQL Server does it. It's an edge that it has over most other databases. I just don't want you to think that when you see that parallelism icon that the work was evenly balanced. Because after all, if I send several of you into the office supply closet to start reading those pages, do I know that you're all going to find the same number of rows that are greater than 7.1 of 2014? Maybe some of the pages have much more frequently active users, and some of the pages have less active users. Data's not evenly balanced. If we think about a users table, I bet the people who started working with Stack Overflow early on have probably tapered off their access, whereas the people who just created their account yesterday, odds are, people with very high user IDs, odds are they have a very recent last access date. But SQL Server doesn't know any of that business logic. It's just roughly throwing out pages trying to see who's going to find data. So when you see parallelism, don't assume that the work was evenly balanced. To prove it in this case, what I'm going to do is I'm going to right-click on that clustered index scan, go into Properties, and I'm going to look at the number of rows that were found by each thread. And you can see that they're not evenly allocated. SQL Server's goal for parallelism is just to make queries faster than they would be with only one CPU core. It's not to make them perfectly fast by evenly distributing data and getting CPU up to 100%. We talk about how to rebalance these threads more in our mastering query tuning classes and mastering server tuning classes. Michael says lazy thread zero. Thread zero is actually the coordinating thread, aka the manager that decides how work should be passed out across all the workers. And did I just say that managers are lazy? No, Michael said that managers are lazy. Okay, so we added that in. Oh, let me switch over one thing on my side here to go get my little notes out on make sure I talked about everything. Yep, cool. All right. So, yep, I got all that. Perfect. Oh, yes, perfect. Okay, cool. So now let's add one more thing onto our query. Let's say order by last access date. Let's go find the people who access the system, and then let's put them organized by last access date. I'm going to hit execute. The SQL Server is able to do it relatively quickly. How did it do it? I don't have an index on last access date. I said that, but let me go through and make sure. Yeah, I don't have an index on last access date. So how did SQL Server accomplish this query in plain English? To think about it, let's look at the contents of our data again. Let's say select star from DBO users with no where clause. Just look at the contents of the table. And the contents of the table here, see how it's organized by ID going down the left-hand side. It's not organized by last access date, which is out over here. Some of the rows are, say, for example, 2008, some are 2018, some are 2008, 2016. The dates in here are all over the place. So how did SQL Server execute this query? Well, the first thing that it did was it scanned through the clustered index looking for rows, because this is the only copy of data that we have. Paul says, can any of this be viewed in Azure Data Studio? We're going to focus on SQL Server Management Studio in this class. It's not that I don't want to talk about Azure Data Studio, it's just outside of the scope of this class. So in here, SQL Server scanned through this, and it found all of the rows that matched. But it's got to hold them somewhere, because it's got to go through and sort these people by last access date. So what SQL Server does is exactly what you would do if you had to go do this as a human being. If you had 7,405 pieces of paper, you couldn't possibly remember all of the last access dates and IDs. You're not that bright. Thankfully, you're attractive enough that they keep you around anyway. So what SQL Server does is it allocates a bunch of 8K pieces of paper that are a scratch pad. They're really the same size as regular data pages. I just like to use a little notebook here to illustrate that it's a different concept. So SQL Server writes down the IDs and last access dates so that it can sort them, and then it sorts that data and returns it to the end user. Let's see the proof of that over in the execution plan. That's my select star from users execution plan. Let's go back and get the one for our actual query. So we read these query plans from right to left, and each one of these queries is each one of these icons here is really like a standalone microservice or a standalone application that does specific things. So over here, the first one, the clustered index scan. Clustered index scan is when SQL Server is going to go scan through and find just the rows that match initially. And let's go see what that is. Let's hover our mouse over the clustered index scan and let's zoom in. And these tooltips are kind of weird how they work in terms of the pop-up tooltips from Microsoft. Whenever Microsoft wants to paint information on a screen, they do it one of two ways. Either they do it alphabetically, which makes no sense for explaining how something works, or else they have this shoulder-mounted data cannon, and they load up the data cannon and fire it at the screen. And wherever the data just pastes out randomly, that's where it seems to end up. This is so stupid. There's like actual number of rows read up here, estimated is way down here. Sometimes actual and estimated are next to each other. Sometimes they're scattered across here. So for example, estimated number of executions versus number of executions. Sometimes they have the word actual in front of them. Sometimes they don't. It's just utterly stupid. That's okay. So if we come down to the bottom here, there's a couple of pieces that are interesting because, of course, Microsoft with the data cannon, they don't prioritize important things up top. Instead, they put the important things on the bottom. Who knows how these people think? So what SQL Server is looking for is it's saying, I only want to return the rows that are greater than 7/1 of 2014 here. It's doing filtering inside here when it's scanning through the rows. And then what's it outputting? It's outputting ID and last access date, because those are the only two columns that we need in order to accomplish our query's objective. Our query was asking for IDs and last access dates. So you can think of this arrow right here as a yelled list of IDs and last access dates. Then the next independent microservice that comes along here, this totally separate application, is the sort. And the sort is going to be the one that writes down all these last access dates and IDs and then sorts them. It's also kind of interesting that this whole query was parallelized too as well. So SQL Server broke up this query across multiple threads, sent multiple people into the supply closet, and then they all sorted their results and coordinated them all together on the way out the door. That's pretty cool. Was this more work than the one with no order by? Well, if I only gauge by the number of pages that we read, the number of pages that we read looks about the same. But pages read doesn't include the work that we did in order to sort all of this data. So the first way that we're going to gauge query work is by logical reads. Generally, reading less data makes queries go faster. There's another way that you can estimate query costs. So let's go take a look at that. What I'll do is I'll take two versions of the query. First, I'll take the one with no order by. Then I'll add one in with an order by. Let's run these back to back, and let's go take a look at their execution plans. Now in the top one, the one with no order by, see how up there it says query cost relative to the batch 32%? This one is 68%. What that refers to is if you hover your mouse over the select, SQL Server gives you an estimated subtree cost. Estimated subtree cost is exactly like the project manager's guess from before a query starts. SQL Server does not go back and recalculate actuals. This is only estimates. Estimates are only useful if we're guessing what or trying to understand what SQL Server thought was going to be harder. It's not necessarily true for when we're looking at actual query costs. But that top one costs 5.87. And 5.87 what? Well, Kendra Little came up with this term query bucks. Because see, a long time ago, it used to correspond to how much CPU and I/O work that SQL Server thought it was going to have to do. That was like back in the late 1990s. Microsoft tried to tie it to time, but computers changed so much over the years, and Microsoft never went back and readjusted that calculation. So we just call them query bucks to denote that it's a rough measure of how much the query costs. Generally speaking, the higher the estimated cost goes, the longer that SQL Server thinks it's going to take in order to execute the query. The top one, with no order by, was a query cost of 5.87 query bucks. The bottom one, once we added in the order by, the query cost is up more than double. It's up over 12 query bucks. An order by is harder. When you're asking SQL Server to do this sorting, if there's not an index to support it for you to have already pre-baked that work, then that order by is going to be CPU work that we have to do every single time the query runs. There's also another interesting difference between these two queries. On the top query, see right underneath the estimated subtree cost, there's a memory grant, 72 kilobytes. Who cares? Parallelism needs a tiny amount of memory in order to get started. But if I go down to the bottom query, estimate the memory grant 14 megabytes, that's this. SQL Server has to guess how much sort space is going to be required before the query even starts. And this is a really interesting concept. You can see more details about it if you right-click on the select and go into Properties. Over here under Memory Grant Info, there's all this stuff. Remember I talked about how when Microsoft wants to paint data on a screen, I said sometimes they use the shoulder-mounted data cannon, sometimes they alphabetize. Here they alphabetized, which makes no sense for storytelling either. When SQL Server designed this execution plan, he said, I desire 14 megabytes worth of memory in order to work. Therefore, I am going to request 14 megabytes worth of memory. Now there's nothing else happening on this SQL Server, so SQL Server says, you know what, max query memory, I could give you up to 5 gigs worth of RAM, because there's nothing happening on this particular SQL Server. By default, any one running query can get up to 25% of the SQL Server's RAM. That's kind of terrifying, so I'm going to say it again, because I like to scare you. By default, any one query can get 25% of the SQL Server's RAM. It doesn't take a whole lot of 25% before all of a sudden you're having extreme performance problems. Now here, in this case, we had more than enough memory in order to satisfy this request, so SQL Server decided to grant this query 14 megabytes worth of RAM. And then the query did pretty well. He only used about 8 megabytes full of RAM. In a perfect world, if SQL Server estimates the number of, Sarab, that question is kind of unrelated to today's class. You're welcome to email me and we can talk about a consulting engagement, but it's way outside of the scope of this class. In a perfect world, SQL Server gets the estimated number of rows right. SQL Server understands how much data is going to be moving around. In this case, for example, if I look at that clustered index scan, SQL Server had to guess how many rows were going to come back to guess how many rows he was going to be sorting and how much memory he would need for that. You can see a little bit more about that if you click your mouse on this little arrow here. See, SQL Server says estimated number of rows for this, and then the estimated row size. This tells me how much data is going to be moving around, and that helps me calculate how much memory I'm going to need for the sorting. This is so cool. I love this, that SQL Server effectively goes in blindfolded and has to figure all this stuff out before the query starts. Because this query plan is built before the query executes. And Microsoft doesn't go back and change those numbers. Microsoft doesn't say, oh, well, now I'm going to guess 150,000 rows or 120,000 rows. If query execution goes to hell in a handbasket, SQL Server's endlessly optimistic. He's like, maybe this time things will turn out okay. Let's keep using the same estimates and see what happens. It's so adorable. It's endearing. It's charming, of course, as a consultant, because I make money when these mistakes happen. All right, let's change something else about the query. Let's take that same query, but instead of just selecting ID, let's say select star. Now, how does SQL Server execute this query? Well, the same basic idea still holds true. I'm going to have to scan through the table, finding all of the rows that match. But now, when it comes time to write down the columns, what am I going to write down? Let's go take a look. Let's look at the execution plan, and let's read it from right to left. The plan still looks the same. We have a clustered index scan followed by a sort. But let's hover our mouse over that clustered index scan. And now, because we asked for all of this data, now that arrow coming out of here, it's a whole lot more stuff, which is way more stuff that poor sort has to write down. And now you see on that sort cost, the sort is now ballooned up to 97% of the cost of the query. And it's not even 97% of the cost is the big problem. The other thing is that it's 97% of a much higher cost. So let's highlight both of those queries and let's run them both back to back and take a look at their compared execution plans. If I go look at their execution plans, they look the same. But if you hover your mouse over that first select, estimated subtree cost is 13, like 12.58 query bucks. And then down here, when I said select star, our estimated subtree cost went up to 876. 876. Query cost went up like 100 times. I'm really bad at math. I don't have a problem with you doing select star. Remember, in the beginning, when I did select star from DBO users, if I go back and do just plain old select star from DBO users, that's not hard on the SQL Server. SQL Server can do that even with no where clause because the table's relatively small and the cost on that query was pretty tiny. It was less than 6 query bucks. But as soon as you start sorting all of it, as soon as you start sorting all of it, that's where our query cost absolutely explodes. And I like to tell people, as long as you're going to be doing sorting, I would much rather have you do that sorting on the application tier. SQL Server, the cost on licensing for Enterprise Edition is $7,000 US per core. It's a really expensive place to do sorting on queries. Application servers are $0 per core, so that's a much more effective way to do that. Now, over in chat, Preet has a suggestion. In fact, Preet says an answer. Preet says the reason why this is happening is that last access date isn't indexed. I love it when people help me teach my training classes. So we'll say create index last access date on DBO users last access date. And so Preet's solution by creating that index is that now when we run this query again, all of a sudden SQL Server will use it. So is that query doing better? Bad news, Preet. You make the query worse. We'll come back to that in a minute. So I'm going to go ahead and drop that index, and we'll come back to that here in a minute. Drop index on users, last access date, boom. He said, Preet was like, oh, I was referring to another comment. So I'll give y'all a piece of advice. I'll give y'all a piece of advice that really holds true whenever you're attending webcasts or training classes or whatever. Never, ever, ever give answers. You are not the instructor. Stop trying to teach the course. Don't try to answer other people's questions. I get that you want to be helpful, but you look like an idiot when you get busted. Don't do that. Instead of giving an answer, ask, would creating an index help in this situation? And then that way you look like someone diligent who's trying to learn, and you might get rewarded with the instructor saying that you have a good question instead of the instructor saying, boom, you suck. Onwards we go. I always feel guilty about that, but it always drives me crazy. People give answers, and I'm like, you're wrong. That's why you're in the class. That's why you're here. If you knew what you were doing, you'd be listening to someone else. So when I compare those two, Connie says it's a good way to deal with your boss too, and that's absolutely true. I deal that way with my clients all the time. I'm like, oh, so what do you think this, with this approach right here might help? So when I got these two queries right here between select ID and select star, you can see that the one where we're doing select star is stratospherically more expensive. And often folks will say that, hey, look, I have to bring back select star because my application needs it for all kinds of things. Well, this really starts to get ugly the more often that the query runs. Mark says, waiting to see how much the viewer count drops off because someone got scolded. Bad news, Mark. It actually happens the exact opposite. People love to watch things like that. So, as you'll see from the comments inside there. So, it gets even worse when this query runs more often. So, let's take this and we'll say go 100. Whenever you put a number after the go, it's really funny, even though it's been this way for like 20 years, it still gets flagged as IntelliSense as something that isn't correct, but it actually works. What this does is it just runs the query 100 times. Now, if I go look at Task Manager while this is happening, CPU is up at like, 60, 70%. The CPU is just going through the roof as SQL Server rebuilds this over and over and over again. There's nothing changing inside the database. Nobody's doing inserts, updates, and deletes, and yet this thing is just absolutely hammering my CPU while these selects run over and over again. When we think about building execution plans, we think that what SQL Server should do is scan the table, write down those last access dates and IDs, do the sorting, and then, hey, maybe we hold on to this for a little while. Maybe we hold on to this for 10 seconds or 30 seconds, especially if there's no memory pressure. After all, SQL Server already caches data up in memory. Why not also cache these for a little while just to see what happens? But that's not what SQL Server does. SQL Server throws these away every time the query runs. It doesn't matter if the database is read-only. It doesn't matter if no rows have changed. It doesn't even matter if 100 people run the same exact query at the same time. SQL Server still rebuilds this wheel every single or reinvents this wheel every single time the query runs. I know my developers will often say, hey, my developers will often say, hey, I can run this query again because the data's in cache. The data pages are, but the results are not. 3D Noob says, Go 100, is this new? No, this has been here for 20 years. Don't be ashamed for not knowing. No one has any need to do that. After all, how often is it really going to come in handy? This is like a presenter's trick. And in fact, if I would be more disappointed in the people who do use it on a regular basis, so don't feel bad about that. All right, so we're going to need a way to make this query run faster. If this is the kind of thing that our application runs all the time, we're going to need a way to run queries like this more quickly, and that is where non-clustered indexes come in, aka reporting copies of a table. Now, this is really related to a question that Osmo Look has right now over in chat. Osmo Look says, I have a table with like 200 columns, and most of the time I only need a subset of them. Should I break this across multiple tables? Osmo, you are not alone at all. Or Oso, you're not awesome Look. Big O, that's what I'm going to call you. Big O, you are not alone. I get that question from clients all the time. They think about breaking up or vertically partitioning table. All you have to do is create indexes instead. An index is like a reporting copy of a table. So let's go see how it works. So I'm going to say, create index last access date ID on DBO users last access date ID. Then I'm going to, as that runs, I'm going to write what I call a visualization query. I'm going to say select last access date ID from DBO users, DBO users, order by last access date and ID. So this, when I run that create index statement up at the top, SQL Server builds a copy of the table that only has last access date and ID. For those of you who are following along with the handouts, if you downloaded the PDFs, first off, I love you for doing what you're told. This is the black pieces of paper on the handouts. The black piece of paper is exactly how SQL Server stores this index that we just created. It's just a list of last access dates and IDs. So this immediately makes you realize a few things. An index is literally a copy of a table. But with non-clustered indexes, you can pick and choose which columns are on there. Whereas with the clustered index, it's all the columns, whether you want it or not. This is literally double the table. It's not double the space, though, because, of course, this index is going to be much smaller since it doesn't have as many columns. But it is a double copy of the table because every time you insert a row, you have to insert that data across both copies of the table. Every time you delete a row, you have to delete it across both copies of the table. You want enough indexes to make your queries go fast, but not so many indexes that they slow down deletes, updates, and inserts. Indexes are a magical tool for query performance when we need them. So in order to understand how much better they are, let's go take a look now that we have that index. And let's go back and run our select ID. I'm going to say, go get the ID from the users table where last access date is greater than 7/1 of 2014. And look at how much better that query plan is now. Now we have something different on there called an index seek. And it gives the name of the index, last access date and ID. Before, we had a scan, which meant that SQL Server started reading at one end of the table and read until it found enough data to give you the answers you were looking for, which in our case at the time was the whole entire table. Here, SQL Server can dive bomb in and only read exactly what it needs in order to satisfy your query. It's reading less rows and it's reading less columns. Because before, we had to read these entire 8K pages, which were stuffed with all kinds of data that we didn't give a damn about. And like the problem Big O is having, he's like, I don't want to read all this data I don't care about. That's where a non-clustered index comes in that only has the data that you want. Let's see how much of an impact that makes. What I'm going to do is I'm going to start a new window just to keep things clean. I'm going to say set statistics IO on. And then Jeff, what does Jeff do? Hey, Jeff. Remember when I said something just a second ago? I said, like, don't ever make statements in a class. I said, ask questions. You're really close there. That first one kind of sounds like a statement. Just be careful about that. You don't want me like slapping my hands together and getting all angry. Remember that. We'll come back to that though. So I'm going to take that exact same query that we had, and I'm going to say set statistics IO on. Then I'm going to run the query two ways. First, I'm going to say from DBO users with index equals 1. And then on the second one, I'm going to let SQL Server choose. What index equals 1 does is it tells SQL Server, I want you to use the clustered index of the table. Clustered index is always index ID number 1, which just kind of works out fancy for me as a presenter. Then I'm going to let SQL Server choose which index it wants to use. Let's go take a look at these two execution plans. Oh, look at what a difference the index makes. The plan is tighter. It doesn't have the sort anymore. It doesn't have the parallelism on there. It doesn't need to go parallel anymore because it's so much less work. Let's compare the logical reads between the two queries. Before, when we were doing the clustered index scan, we were reading about 8,000 pages. Now that we have the index, we read 20 times less data. 20 times less reads plus no sort. It's a win all the way around. Let's look at it another way. Query cost. Let's hover our mouse over the old version. The old version was about 13 query bucks. The new version, when SQL Server's doing this, it's down to less than 1 query buck. It's like 41 query cents. Indexes make queries run faster a couple of different ways. One is that it helps you read less data. The other is that it helps you do less CPU work in terms of sorts. Now, they're usually better. Sometimes they can make things worse. Instead of doing just ID, let's do select star. So I'm going to say select star from DBO users. In the first one, I'm still doing a force of a clustered index scan. In the second one, I'm letting SQL Server choose. And in the first one, where we had that clustered index scan, which one of these two is better? We have something new in the second query. Now, several of you have asked several questions over in chat, and they're all great questions. I'm going to finish up this point, and then I'll switch over to Q&A. By all means, continue to ask questions if you want. Just don't post answers over in the chat. That's kind of ugly. So we have something new down here inside the second execution plan that we didn't have before. This something is called a key lookup. So what did SQL Server do here? In order to illustrate it, I'm going to run just our newer query with the index so that I can have it right next to the execution plan. I asked for select star. SQL Server used this index. He seeked in on July the 1st of 2014, made a list of all the last access dates and IDs that matched, and then he did a key lookup. He took the ID from this index and used it to look up the row on this index to get the rest of the columns that we needed that weren't up here, because I asked for select star. If I hover my mouse over this part down here, I can see a couple of interesting things. One of them is the output list. This is all the stuff that we asked for in our query because we asked for select star. We didn't have all this stuff on the index, so SQL Server had to go look this up. Well, is this better than doing a table scan? Because before we did the table scan, let's switch back over here and take a look at both of them. Before we did the table scan, now we do this key lookup. Which one of them is doing less logical reads? Using the index made things worse. Using the index, we read more pages than there are in the table. More than are in the entire. There's only 8,000 pages in the whole table. We read 455,000 pages. That's banana pants insane. How did that number get so high? Well, it's because of something that I really think is counterintuitive in SQL Server. I wish the key lookups were three-dimensional. I wish they popped off the page based on the number of times that they were executed. Because a lot of us will see this and we'll just think, it's a key lookup. How bad can it be? Well, the problem is the number of executions. We did this 150,000 times. Because for every row that we found in this index seek, every time we found an ID here, we had to go take that ID and go look up that ID. And since we found 140,000 different people, we had to look up 148,000 different people with this key lookup. So performance actually got worse with the index instead of better. I wish I could teach you everything inside a single 2-hour class. I wish I could teach you all the problems that are inside SQL Server, all the ways to work around some of those problems. But I kind of think of this class as the opening gateway in a whole new world. You know, where, I don't know why I always do the hand motion exactly the same way. I don't even think that's in the movie, but it opens up a whole new world where you go, wait a minute, hold on. That isn't quite the right way that I would want this to happen. And you're right. This is what performance tuning is all about. And because I can't teach you all of that inside a single 2-hour class, that's where the rest of my classes, like my fundamentals weeks, come in. In May, I'm teaching a 1-week series of class with fundamentals on index tuning, query tuning, how I use the first responder kit, and much more. You can sign up for that over at brentozar.com/go/fun. Now, I do have to warn you, that one's not free. That one is what they call expensive, because someone has to pay for all of my habits. I like wine. I like shopping. I like restaurants. I like all kinds of vacations. I like all kinds of things that are expensive. So if you want to look as smart as I look, which is probably a trick-loaded question, then that's where the training classes come in. Now, let's go hit some of the questions that you popped up over in the YouTube chat. So over in the YouTube chat, I'm going to scroll down from the top of the YouTube chat because there were several. Whoops, let me click over here and get my mouse up there so I can scroll back. John says, what if an index is sorted ascending or descending? Will SQL Server use it? Let me go show that with a demo because it's a great question. Not that all the questions aren't great. Most of the questions are actually pretty good. Let's say select top 100's last access date and ID from DBO users, order by last access date. Now I have an index on last access date and ID, and here SQL Server will use it. SQL Server is scanning that index. Now at first you might think scanning is bad, but bear with me. Scan means that we're going to start at one end of the index and begin reading until we find enough rows that match what we're looking for. I only asked for the top 100. So what SQL Server did, if I hover my mouse over that index scan, you see how SQL Server says number of rows read? SQL Server only read 100 rows and then was able to stop reading. It didn't need to read that many data pages. I can prove that by saying set statistics IO on. If I say that and then rerun the query and go look at the messages, we only read 3 8K pages and bailed out. Scan doesn't necessarily mean bad, doesn't mean we read the whole thing. Now, if you remember when I created that index, I didn't say anything about ascending or descending. So SQL Server does ascending by default. If I right-click on this index scan and I go over into properties, you'll see something down here that says scan direction forward. Now, let's go the opposite way. Let's say order by last access date descending. Can SQL Server use that index? And it does. Let's take a look at that index scan and go properties. And SQL Server is able to scan the index backwards as well. Just like if I told you to go get the phone book, you probably don't remember what a phone book is, kiddo, but if I told you to go get a phone book and give me the first 100 people in the phone book ordered by last name descending, you just go to the end of the book and read backwards. That's exactly the same thing that SQL Server can do, which is kind of cool. Oops, wrong button. Let's go to that. See what the next question is here. So Daniel says, is there a point where your table gets too many columns and you would split it vertically versus making more indexes? I worry about having too many indexes, but I don't know what the trade-off line is. Well, if you split it into multiple tables, you still have to do writes to keep that in sync, right? Generally speaking, if someone starts asking about too many columns, what I steer them towards is the only database book that I keep on my bookshelf. And I don't say that because I read it very often. I say that just because I have to show it to clients very often. Relational Database Design for SQL Server by Lewis Davidson. It is not a small book, but if you want to learn how to design your tables better, it's fantastic. I would totally start there. The problem, of course, is with making database schema design changes is that it also requires application changes, so it's fairly unusual that people are willing to take that jump. Next up, let's see here. Lewis says, let me go back to that. Lewis says, is there any difference between using the ID in a clustered, non-clustered index and not using it? No, and let me show you that. So when I created this index, let's pop a new window. When I created this index, I said create index last access date ID on DBO users, last access date and ID. Then I said create, and I'm going to say another one, create index last access date on DBO users, last access date. These two indexes are effectively the same. It doesn't really matter as long as the first column is extremely selective. SQL Server always includes the ID of the table, whether you ask for it or not, because SQL Server has to be able to join between these two objects. If it finds a row in here, it has to be able to join back over to here to find other things on this index like display name, age, location, and so forth. It is technically sorted. The top one is sorted by ID. So technically, the top one's a little bit different because if I had duplicate last access dates, then these are guaranteed to be sorted in order, in ID order after that last access date. But effectively, those two are the same. Then another way to see that is with SP Blitz Index, table name equals users. The SP Blitz Index is part of our open source first responder kit. And what that does is it shows you information about a table's index designs. Here, I have the index on last access date, and then I have the index on last access date and ID. Check out their sizes. They're the same. Because both of them have to have ID in it guaranteed so that they can join back over to the clustered index there. All right, let's come back over to the chat. Next up on the incoming questions, KB says, Brent, does it matter what type of data type that you use as an index? So you don't get to choose the data type of the index. You only get to choose the data type when you design the table. As you're designing the table, each column, that's where you choose the data type, but you don't get to pick and choose what data type is used on the index itself. There are some cast and convert tricks that you can do, and I teach you those in the Mastering Index Tuning class, but generally speaking, that's a super rare edge case and has all kinds of drawbacks. Next up, Buyer says, is the clustered index equity column part of every non-clustered index? Yes. If so, why does it need to be added to the last access date and ID index? Because, Buyer, not everyone is as smart as you are. A lot of people out there who are watching the YouTube video, they won't connect that the ID has to be part of every non-clustered index too. So I explicitly created in there in order to make teaching easier. But good on you for recognizing that. Let's see here. Next up, also says, or Big O says, if the table has 20 million rows and most of the time I'm selecting only the newest data, do I need to sort the indexes descending? No, hopefully you've seen by now that it doesn't matter which one of those two ways that you do it. There are edge cases where it does matter, and I cover those in the Mastering Index Tuning class, but they're really rare edge cases. Michael says, I must know absolutely nothing about table design, given that the book is 1,154 pages. Yeah, it's pretty serious. Patrick says, what's the highest number of indexes you've ever seen on a table? In a customer table in a real-world situation, 174. And I tell that story and the situation behind it in the Mastering Index Tuning class as well. You might wonder, too, when I talk about classes, I often talk about my fundamentals and my mastering classes. The fundamentals classes tend to be 1 day long each. Like 1 day on index tuning, 1 day on query tuning, 1 day on parameter sniffing, 1 day on tempdb, 1 day on column store, things like that. This, just what you've seen so far in the first hour of this class, gives you a rough indication of how deep that we go into in the mastering classes. Most people are blown away by what they learn in the fundamentals classes, so by all means start there with fundamentals week, and don't try to register for the mastering classes until you've been through fundamentals. I can't tell you how many times I've had someone who's been like, I've been in this business for 20 years. I know the fundamentals. And then they go to try to attend the mastering classes and they're like, sweet potato, I did not realize how little I knew. And the way that I'd explain that is that just look, if you haven't been to a formal SQL Server training class ever, well, of course you don't know how that stuff works. Tony says, let's switch back over to here. Tony says, as a DBA, is it solely my responsibility to include indexes on tables, or is it the programmer's task to do so? Google for Brent Ozar, DBA job duties, and in there I've got a blog post that lays down the different job duties for different types of DBAs and developers, and it lays it out pretty clearly in there. Dimitri says, are the live mastering classes coming back too? No, I actually offered them for sale during Black Friday, and I only had 3 people sign up. People really seem to prefer, and they was on sale too, so I'm never bringing those back. Those are definitely recorded only from here on out, whereas a bunch of people signed up for the live fundamentals. And then Big O says, as a SQL master, what would be the easiest and best tip you can give for making good indexes? Attend my training class. Right? Like I'm giving you tons of stuff for free here. And speaking of which, let's go back to the free stuff. All right. So to close out some of these windows here from our first hour and just to get a rough idea of where we're at, So what we just did was we created an index on last access date in order to make some of our work easier, in order to make some of queries faster over and over each time that they ran. And we saw this weird problem where SQL Server has to make these decisions between which one should it do, a clustered index scan versus an index seek and a key lookup. SQL Server designs indexes, or I'm sorry, SQL Server designs query plans before your query even starts. There are kind of two phases to query execution. The first phase is designing the execution plan. The second phase is actually executing the plan. Kind of think of it as like building a custom house. If you've ever wanted to build a custom house, the first thing that you do is you go to an architect and they go sketch out a blueprint for you. Then you take that blueprint over to a builder and the builder starts bringing that house to life. But the architect, he's not lifting any hammers out there with you. And the builder, he's not sketching out the blueprint. Those are two totally separate job descriptions with a wall in between them. This is the same thing here. SQL Server has to make choices like this before the query even starts to execute. So how does it figure out which one of these makes the most sense? The first thing that it has to do is it has to figure out how many rows are going to match what you're looking for. So for example, if I say, go find me all the users that are greater than July the 1st of 2014, SQL Server has to guess how many rows that's going to be. And if I hover my mouse, you see how on this execution plan it says things like 148,000 of 148,000. What that means is we brought back 148,000 rows of an estimated 148,000 rows. That's pretty good. You can see more details about it over here. Estimated number of rows per execution. Each time we did this, we expected to bring back 148,000 rows. Actual number of rows, 148,000. So where's that coming from? Well, let's go take a look at our database structure. And for every index that we have, SQL Server automatically builds, let me go through and drop that other unrelated index that we used for demos, last access date on DBO users, and then go execute that again, put our estimate up here again so you can see it, refresh this, right on this. So every time that you create an index, SQL Server automatically creates a statistic with the same name. A statistic is one 8K page worth of metadata that describes the contents of the object that we're talking about. So since we have an index on last access date, SQL Server also has now built a statistic on last access date. And this is what it uses in order to guess how many rows are going to come back. Let's go take a look and see how that works. I'm going to run dbcc show statistics, DBO users, and last access date ID. dbcc show statistics is one of those commands that presenters will use, and I don't want you to think that I use it every day when I'm going through and doing my consulting. I don't want you to think that I'm using this all the time, but knowing that it exists and knowing how it works helps you understand how SQL Server builds its execution plans. It's totally safe to run. It runs instantaneously. Even in production, it's totally safe to run. Doesn't affect anybody else's session. All you have to do is pass in the table name and the statistic name that you're dealing with. And it tells you a bunch of interesting stuff. For example, at the time that this statistic was created, there were 299,000 rows in the table, and SQL Server sampled all of them. SQL Server is just like a political pollster. As your data grows into tens of millions or billions of rows, SQL Server can't afford to take the time to talk to every single person in the country to figure out how they're going to vote. So SQL Server will randomly sample sections of the population in order to get a rough feel of what the data looks like. SQL Server sampling is exactly like political pollsters. Sometimes it's right, sometimes it's hilariously incorrect. Here, though, it scanned the entire table, all 299,000 rows. And this statistic is based on last access date. So then I have this histogram here. And this histogram tells me up to 201 buckets worth of data distribution that helps me figure out roughly how many rows are going to match. So for example, given that my query says where last access date is greater than 7/1 of 2014, what SQL Server does is come down this list. SQL Server goes down to the point of 2014 0701. Let's take a look at that. Whoops. Let me get my mouse pointer out the way. There we go. So you notice there's not a bucket for exactly July the 1st of 2014. SQL Server didn't break this up in even sizes. Some of them are really small date ranges. Some of them are really big date ranges. SQL Server is trying to paint the best picture that it can given just one 8K page for statistics and only 201 buckets in order to describe our data. So how's SQL Server coming up with this number? SQL Server says, well, some of the people in this bucket, which this bucket that's highlighted is in between December 2013 and November of 2014, some of the people in this bucket, plus all of the rest of the people in all of the rest of the buckets are going to match because they're all newer dates. And I've asked for greater than July the 1st of 2014. That is exactly how SQL Server comes up with these estimates. Now, one of you over in chat, Lewis, says, how do index stats become outdated? All right, let's think through that for a second. Your data changes. In the case of last access date, people are logging in all the time. So what happens if a bunch of people go log in right now? SQL Server won't know about that because if we go look at show statistics and we go look at the newest dates that are in this table, the newest dates that are in this table are really old. So if a bunch of people logged in right now and I said, go show me all the people who've logged in the last hour, SQL Server would give me really terrible estimates about, excuse me, my throat burns out because I get really excited for talking really loudly. It's disturbing how excited I get about talking about databases. So SQL Server wouldn't know how many rows are going to match, and so its estimates would be wrong. And over time, they would get more and more skewed. Now, that only affects some statistics, though. Because imagine, for example, a statistic on display name. Let's go create one. If I say create index display name on DBO users display name, then I go take a look at the statistics on that. Copy and paste. If I go take a look at the statistics on that, and it shows you the most common names out there. For example, if I'm looking for Alexander, I can tell you that, look at equal row. I need to move this over just a little so that I can point at it. We'll put this over here. So if I look at Alexander, for example, I can tell you that there are exactly 98 people named Alexander in the database. Okay, what happens if we don't update these statistics for a month or 2 months Is the number of Alexanders really going to be that far off? Odds are no. It's not like all of a sudden everybody named Alexander is desperately urgent to go create a Stack Overflow account. The data will still look roughly the same in distribution, and this is the case for most statistics out there. This statistic, you could probably go without updating it for a year, and it's not going to make that big of a difference. But with other statistics, like things like last access date or sales date in a data warehouse, it can absolutely make a huge difference. All right, let's stop for a second and hit a couple of questions. Coglia says, is it possible to get a local discount on classes because the currency in my country is very high, even though the classes are very expensive? No, unfortunately, I have to pay my bills in US dollars. I can't take your money and then pay my bills in that currency and be like, look, it was a lot of money over there in Kazakhstan. Can I pay my US bills with that? They're like, no, sorry, that only buys like a burger and fries here. It sucks, right? I wish that wasn't the case. What I wish would, I mean, I say this, but a cool way for me to do this would be for me to move to a place that was really cheap. And then I could lower my prices. Except I wouldn't. I'd probably just keep charging a lot of money to those greedy Americans and then live in a giant mansion in Kazakhstan. Danny says, I have legacy CDC import processes. The table has an ID primary key. The table is updated by update cert. Rebuild NCI is timing out. Okay. I don't see a question in there, so it sounds like you're just keeping me posted. Keep up the good work, Chief. All right, let's come back over to statistics. Sometimes people just feel like they need to share, I suppose. So back over on our statistics, back over on our stats on last access date. So in the case of my really simple query here, I say really simple, it's not beautifully simple, but in the case of this query here, SQL Server was able to easily understand my last access date filter, and it was able to really quickly say, oh, all I have to do is seek to 7/1 of 2014 down here in these stats, and I can come up with really good estimates on how many people are living in last access the system inside this date range. Stats work really well when your query is easy to understand. But the harder that your query is to understand, the less useful statistics can be. Let's give you an example. I'm going to say where last access date is greater than 7/1 and last access date is less than or equal to 2014-08-01. So you can see that I'm getting everyone who accessed the system inside of July of 2014. I should say, let's say greater than equal to and then less than. There we go. That's what I should have done. Now, I'm going to write that same query a different way. Select star from DBO users, where the year of last access date equals 2014, and month of last access date equals 7. Order by last access date. Now, with this in mind, let's delete all this out to make it easier to fit on the page. With this in mind, the first thing that I want to go do is just make sure that these two queries return the same results. So the top query returns 728 rows. The bottom query also returns 728 rows. So they are the exact same way of accomplishing the goals. As far as my users are concerned who wrote this query, those two queries do exactly the same thing, but not necessarily to SQL Server. If I go look at their execution plans, the top one, when I wrote it in a way that was really easy to understand, SQL Server did really good estimates. SQL Server estimated that about 700 rows were going to come back, 694, and in actuality, 728 rows came back. But when I got fancy with the query, when I used my year and month functions, If I look at the estimates on that one, they're not as good. SQL Server estimated that 1,500 rows would come back, when in reality only 728 rows came back. Its estimates were wrong. Generally speaking, the closer that your estimates are, the better your query plan is going to be. When you start to see your estimates become more than 10x off, meaning SQL Server either estimated 10 times too much or 10 times too low number of rows were going to come back, that's when your heartache really begins. That's when you start doing query tuning. And in the case of query tuning, most of my work is telling people, I need you to make your queries as easy for human beings to understand as possible. If, for example, you look at a query and you can't guess how many rows are going to come back, especially when we start talking about multiple joins, odds are neither can SQL Server. And that's not an index problem or a database problem. That's just making your query as simple and easy to understand as possible so that you get the best estimates as practical. Now, let's come back over to the questions to finish things up here. Big O says, if I have a query where ID and account name index is needed and another index is needed, can I create a... That's a great question for fundamentals of index tuning. I go into that, like creating multiple indexes and how to satisfy multiple queries with the same index. I talk about that in detail in fundamentals of index tuning. So check that out during fundamentals week. Connie says, oh my goodness, I am so triggered with the functions query. This is my work life, horrible queries that I can't change. And there are things that you can do to make it better that start to get into, say, the mastering class level, where I tell you how you can make some of those better by just doing index changes. They're kind of absolutely crazy. I'm going to give you one peek of an example just to show you the depth to which the mastering classes go. So say that right now you have this query here, and businesses, you're not allowed to change this query. It's got to go faster. And you're like, oh my God, but right now when I do this, let's go get set statistics IO on. So right now when I do this, it does like 3,000 logical reads. I don't know how I'm supposed to make that faster. And right now, it's scanning the entire index. It's scanning the whole thing start to finish because I can't just magically seek in to one particular year and month. Well, here's the trick. Create view, DBO view users with schema binding as select year of last access date as last access date year, month of last access date as last access date mo, ID from DBO users, go. Now, normally when we think of views, they're just syntactical sugar that helps make our queries easier. Here's where the magic starts. Create unique clustered index, CL, on DBO view users. And we're going to sort it on last access date year, last access date month, ID. What this does is it builds the index or builds that view to disk permanently and keeps it up to date automatically. Every time people are doing inserts, updates, and deletes against the users table, it automatically keeps this view up to date. Right about now, who's the person who was triggered? Connie goes, yeah, it doesn't help me because I told you I can't change the queries. I can't get them to change the queries to point to this view. Connie, hold on. I just relaxed. Breathe in a paper bag. Let's go take a look and see what SQL Server does now. And go take a look at this execution plan. And of course, it doesn't do what I want it to do. It's supposed to use the indexed view. It's supposed to use the indexed view, so now why isn't it? This is part of my life. Rookie says, is the index updated synchronously? It's updated synchronously, yes. Did I get order by? Oh, let's do last access date too. That's the other problem. Last access date. Now I'm and then let's see what happens there if I do. I don't know that that's gonna, let's give it a shot though. Create or alter, execute. It'd be really funny because this is what happens when I go off topic and I don't plan the demos ahead of time. Nope, it's still not working. Well, so I teach you how it does work over in that class, and I teach you about the gotchas with that as well. Michael says, is that called an indexed view? Yes, absolutely. And I think I missed one other question that came in on there. Come up a little. Lewis says Brent is, oh no, Troy. Troy says, would the function between work better, worse, or different? That's one of those examples of why I give y'all access to the database and the queries so that you can go test, because I kind of want you to go experiment so that you can see, get your questions answered long term every time, because you're going to have this question with every T-SQL statement, every piece of syntax. You're always going to be asking what's faster or what's slower. Now you know how to go about looking at that journey by measuring with logical reads, for example. Next up, Lewis says, is it better to have a large query with many operations or break the query into smaller ones using CTs and temp tables? I covered that in the Mastering Query Tuning class. We spend about an hour on that, giving examples of when it's better to combine queries, then when it's better to break them down into pieces. Then you get a 1-hour lab where you have a bunch of queries and you have to figure out which approach you're supposed to take. Then I do the lab again in front of you so that you can see. Anvi says, hi Brent, yesterday you mentioned your fundamentals and master classes are available on a perpetual license. I've looked around your website, but I can't seem to find that particular product. Yes, I'll show you. So if we go to brentozar.com and then we click training up at the top. So I'm going to click training up there. So I'm going to click training up at the top. Then you have all this cool stuff. See this right here, fundamentals and mastering bundle. So you want if you want other products, you can go click on that. But the one you asked for was fundamentals and mastering. And most people do this. So you're going to click on fundamentals and mastering. And then you see how this button right here, this is the button that it's very important that you click. This is the button that says, I want to give Brent all of my money. You're going to click that button and then you get to choose how you want it. Would you like to pay me every year, or would you like to pay me once for lifetime access? Isn't that kind of cool? Wee-hee! Love that. All right. So that gives you enough to get started there. We've been going for about 90 minutes. I usually aim for about that when we're doing this course because I find that people lose track and need to go to the bathroom after that. So what did we cover inside here? The most important things that we covered are the clustered index is the table itself. However you decide to organize the table itself, you get one column basically. You can use multiple columns, but it still comes down to that first column. As to how that table is organized, if you want to query by other columns, and let's face it, everyone always wants to. If you want to query by other columns, just swallowed my throat lozenge, then you're probably going to be doing table scans. This is where non-clustered indexes come in. Non-clustered indexes are great for like reporting copies of the table. It helps you reduce logical reads and it helps you reduce sorting with CPU as well. In order to figure out which index gets used, SQL Server uses statistics. A statistics is one 8K page worth of metadata that describes the contents of this object that's involved in the question. You can keep your statistics up to date, but that's still not enough. Your query has to be easy enough for the optimizer to understand what it's looking for and be able to use statistics in order to answer those questions. Now, this is the start of a whole new world. So folks are asking things like, for example, SQL Pilot says, would that index view be used with recompile hint in the query? You can figure that out in the Mastering Index Tuning class, where we go through and spend about 45 minutes on index views, filtered indexes, computed columns, all kinds of stuff like that. Eve says, what do you recommend about executing missing indexes? We cover that in the Fundamentals class. So to finish up, your next step after this class would be Fundamentals Week. If you go to brentozar.com/go/fun, we spend a week covering how I use the first responder kit, the fundamentals of index tuning, which goes into missing indexes in detail, fundamentals of query tuning, fundamentals of tempdb, and more. You can learn more about that over at brentozar.com/go/fun. Daniel says, where can I learn about more where it would be better to use multiple column clustered indexes? That would be the Mastering Index Tuning class. Just don't go through the mastering classes until you've already hit fundamentals. I can't tell you how many times people have said, I thought I understood the fundamentals, but I don't. And I'll give you a great example of how you should be in fundamentals instead of mastering. If I say, what order should the columns be in an index? And you say it's based on the selectivity of the data, you're wrong, and you should go to the Fundamentals of Index Tuning class before you go to the Mastering Index Tuning class. All right, there we go. Hope y'all had fun and learned something, and I will see you around at office hours and whatnot. Thanks y'all for stopping by, and see you at Fundamentals Week. Adios.